Now, by now, like we have learned the difference between the learning and memory. So broadly we can say the difference between learning and memory is learning is to acquire certain new information, and because of the acquisition of that information you change your behavior or change any response to a particular stimulus, and that learning, if it stays for certain period in the brain, then that is called as memory. Okay, broadly we can say this, like not the exact medical definition, but broadly to understand the thing, learning is to learn about something, to acquire certain new information, and if we retain that information for a certain period in our brain, then that is called as memory. So based on this we can say the memory, it has two or three types, either the short term memory, the second is long term memory, and few of the books they say the long term memory is intermediate long term memory, and third is the long term memory. The basic difference between these three types is short term memory is it stays for certain time period, we can say for certain seconds or at the max for certain minutes, like 2 to 5 minutes or 1 to 2 minutes. So that is the short term memory, and intermediate is which stays from days to few weeks, then it will fade away. That is the intermediate long term. And the long term memory is it can be recalled up to either throughout the lifetime or up to certain years, like few of the memories of your childhood you still remember, right? And like say there are the certain incidents that happened in your life and you remember those incidents now, like now the age of 19-20, you may retain those certain incidents that happened in your childhood up at the age of the 40 or the 50, but not all the 100% of the events that happened. It will keep on reducing 100 to 90 or 80%. Okay, so we can say up to the years, certain years, or some of them you will remember throughout your life. That is the long term memory. Okay, now if we say what is memory, it's very easy to say the retention and storage of that new acquired information is the memory. Then how it is stored, where exactly it is stored? So we can say like there is a term that's called as memory trace or memory traces. What is this? Actually the memory is, it's nothing, it's not a certain thing कि यहाँ पे ये चीज़ है and you say okay this is the memory. No, it is not of the circular shape, it is of the rectangle. And some say no, it's triangular. No, that's not the thing. The memory is, it is like we can say the change in the basic sensitivity of a synaptic transmission. Okay, synaptic transmission, like say there is one neuron, one second, like say this is the one neuron and it forms synapse with the second neuron. Okay, the second neuron. So there is a synapse over here. This synaptic transmission, it will get altered. Either it will increase, say there is one neuron over here, it has got certain so many neurons. Initially when you have not acquired any information, now there are these number 1, 2, 3 and 4 neurons, they are lying over here. But this major, the initial neuron, this neuron, it has got only the synaptic transmission with this one neuron. Maybe there, like there are so many neurons, second, third and fourth and fifth likewise, they are present, but there is no synaptic transmission. When you acquire certain knowledge, then there might be connection with this one. Formation of connection means there is a synapse present, but there was no synaptic transmission happening. Now their synaptic transmission might happen. That is one of the thing. The second is when initially before acquiring that certain information, now there was synaptic transmission happening between this and number 1 neuron. It might get increased after acquiring that information has resulted into increase the transmission or decrease the transmission with this one, or formation of the new transmission with the certain neurons. So these things, this synaptic transmission, the change in the synaptic transmission, either decrease or increase or formation of new. So we can say the synaptic transmission change in the, we can say, one second, this thing, synaptic transmission change, that is the neural basis of memory. And this, like say there was a connection over here with the one neuron, it increased or it formed new connection with this. These are known as memory trace. So these formation of the new memory trace, formation of the new like synapses, or strengthening or weakening of already present synaptic transmission, that is called as the memory trace. So new, or we can say the facilitated pathway, they are known as the memory traces, and these memory traces are nothing but whatever you have acquired the information you have stored in your brain. So that is called as the memory. So now if we look at this synaptic transmission increase or decrease, we can, one sec, so this change in the synaptic transmission, this is called as or known as synaptic plasticity. So the ability to learn and form the memories, it happens because of the ability of neurons to change the way in which they communicate with each other, right? Like these memory traces, the strengthening or facilitation of those synaptic transmission, the ability of the neuron to change the way in which they communicate with each other, that is the neural basis of memory or learning, we can say, and that is known as synaptic plasticity. So synaptic plasticity is the basic fundamental neural basis of the memory. We can say the key to the memory is this synaptic plasticity, and this is nothing but alteration or change in the strength of certain synaptic communication between certain neurons, that is called as synaptic plasticity. So this synaptic plasticity, these changes like in the memory traces, these strengthening of the synaptic transmission happening, it can be either for a short term or for the long term, okay, short or the long term, and it depends, these short or the long term changes, whether it will happen the long term or the short term, it is as a result of the history of discharge at a synapse. Say I will take the example, like there is one neuron over here and this is the second neuron. You repeatedly stimulated this particular neuron, okay, repeatedly stimulated means you start to learn certain things like new topic. So this neuron will get repeatedly stimulated, and because of this repeated stimulation there will be the release of neurotransmitter, and that neurotransmitter will generate EPSP in the postsynaptic neuron, and the action potential will be generated, and that has got certain further neuronal connection, or we can say the synapses. Initially when you haven't read about a certain new topic, there was synaptic transmission happening, but not much or very large amount or at a very large speed this neurotransmitter release was happening, but you stimulated this neuron. Like say आप कहते हो ना कि जैसे electricity connections are there, like there is a feeder, आपके लोकेलिटी में एक मेन ट्रांसफार्मर होता है, वहाँ से कनेक्शन आ रहे हैं हर घर में, ओके, एंड अब ज़रूरी नहीं है कि जो कनेक्शन आ रहे हैं आपके इलेक्ट्रिसिटी के, तो वहाँ पे आपने अपनी लाइट और जो भी है कोई भी इलेक्ट्रिकल अप्लायंसेस वो स्विच ऑन कर रखा है या नहीं, राइट? जैसे इस पर्टिकुलर एक घर में इसमें ऑल द इलेक्ट्रिकल अप्लायंसेस आर स्विच्ड ऑन, but there is a connection with all these 1, 2, 3, 4 houses, but they have switched off their electrical appliances. At one particular time they switch on. So, we can say this similar thing, the synaptic transmission, the synapse is present over there, but these electrical appliances were not switched on. You started reading about the certain new topic, then that certain new topic stimulate this neuron, so automatically switch on the light. Did you get my point? Okay. So, this synaptic transmission will happen, and depending on how aware or how seriously, attentively you have read about that topic, there will be different types, like we can say the strengthening, either there will be increased or less increased or more increased release of the neurotransmitter and stimulation or the generation of EPSP in this postsynaptic neuron, right. So, we can say based on the history of the discharge, like you have read that topic, synaptic transmission happened, now you closed that book. After some time or after 1 hour, 2 hours, if you try to recollect, then who is responsible for recollecting that information you have gathered few hours earlier? This synaptic transmission, because of the history of the discharge that happened 2 hours ago, the synaptic connection, the synaptic conduction between these two neurons will strengthen. That is the main basis of this, we can say, the synaptic plasticity of the memory, and this strengthening of the communication between these two neurons, it may be either due to the change in the presynaptic neuron or due to the change in the postsynaptic neuron. Like in certain conditions, there are so many mechanisms. Broadly, we can say there are the 4 mechanisms, either the post-tetanic potentiation, then there will be the long-term potentiation, and then there can be the long-term depression. Okay. So, that we will talk. So, depending on either bringing about the changes in the presynaptic neuron or the postsynaptic neuron. Out of those, one is the post-tetanic potentiation. Now, what is the post-tetanic potentiation? It is production of enhanced postsynaptic potential in response to the stimulation. It occurs after a brief tetanizing train of the stimuli, that like you started reading about a certain new topic, that will generate the tetanizing train of the stimulus in the presynaptic neuron, and this post-tetanic potentiation, the result of this repeated stimulus, it will last up to the 60 seconds. And what happens when you keep on stimulating, like if you recall back the happening, like any synaptic transmission that happens between the presynaptic neuron and the postsynaptic neuron over here, it is due to, like say, if you stimulate, there is generation of that impulse, it will come, and what happens over here? There will be opening of the calcium channel, there will be the calcium influx, right. So, that calcium influx will happen, will go into the presynaptic membrane, and the vesicles which contain the neurotransmitter, they will attach to the membrane, and exocytosis happens, and that needs calcium. So, the calcium accumulate in the presynaptic neuron because of the repeated stimuli, and intracellular binding sites that keeps the cytoplasmic calcium low are overwhelmed. What does it mean? It means, like say, if I try to draw the diagram of this presynaptic neuron, and this is initial part. Initially, the calcium is present inside, but this calcium is bound to certain binding sites. So, it is not available over here for the vesicle to get attached and release the neurotransmitter. But because of the repeated stimuli, calcium channel opens, extracellular calcium enters in the cell, and whatever the binding site were there, they will totally get saturated. Now, the free calcium will be present, and this free calcium will attach the vesicle to the synaptic membrane and release the neurotransmitter. So, that is the meaning of intracellular binding site that keeps cytoplasmic calcium low. They are overwhelmed, and there will be more and more availability of the free calcium to release the neurotransmitter. That is called as post-tetanic potentiation. Okay. Now, as we know, the habituation and the sensitization, these are two types of the non-associative learning. So, what was the habituation? The learning not to respond to repetition of an insignificant stimulus, right? The best example is जब आप you take a bath and after that you wear the clothes, right? Initially जब आप कपड़े पहनते हो तो because ये जो क्लॉथ है इट इज़ टचिंग योर स्किन, सो टच रिसेप्टर आपके स्टिमुलेट होते हैं ना इनिशियली. तो जैसे आप कपड़े पहनते हो यू बिकम अवेयर कि हाँ मैंने कपड़ा पहना है, बट आपने वो कपड़ा तो थ्रू आउट द डे यू लाइक आपने वो पहना है थ्रू आउट द डे, आप उसको पहन के रखोगे, बट बिकॉज दैट स्टिमुलस टच ऑफ द क्लॉथ टू योर स्किन टच रिसेप्टर इट इज़ इनसिग्निफिकेंट स्टिमुलस, सो यू विल लर्न टू गेट हैबिचुएटेड. आप अवेयर नहीं होगे. अगर वहीं पे उसी पर्टिकुलर एरिया में अगर कुछ आपको इंजरी लगी हुई हो तो जो आपने नॉर्मली कपड़ा पहना हुआ है वो भी आपको बार बार रियलाइज़ कराएगा, वहाँ पे सेंसिटाइजेशन ज़्यादा होएगी, राइट. सो दैट इज़ पहले आप इनअटेंटिवली यू आर नॉट अवेयर अबाउट दिस नॉन सिग्निफिकेंट स्टिमुलस, दैट इज द हैबिचुएशन. सो फर्स्ट टाइम व्हाट इज इट रिस्पॉन्स हैपन्स or the orienting reflex happens. Like if any novel stimulus happens, that is called a new stimulus happens, your body will respond it what is it, or your body will orient itself toward that new reflex. Let's take the example of the corona. जब initially corona आई थी, you know what was the initial name of the corona? Novel coronavirus. If you are not aware about it, novel coronavirus means you will read about it, this coronavirus in the in microbiology subject, coronaviridae, like this is one class of the virus, coronavirus. So they gave the name novel coronavirus because it was new to them. The world didn't know like what is it, that was the what is it response, and now it is called as SARS-CoV-2. That is the name of the scientific name of the coronavirus. SARS is severe acute respiratory syndrome due to coronavirus 2. There was one more coronavirus form, that is the coronavirus 1. That's why, okay, forget about this thing. This is not significant now for now. Okay, this is the insignificant stimulus. So forget about this. Now, like initially when the corona happened, the world was startled, like what is it now. Initially क्या हुआ आपने, PM declared the lockdown, everybody was wearing the mask, everybody was within the house. Now when it has become more, nowadays the cases are rising up to the 60,000, 60K per day. Initially when it happened, the novel stimulus, at that time not only the 6,000 cases per day were there, but we were very much aware. Now there are the 60,000 cases, we have become habituated to it. It evokes less and less response as it is repeated, and eventually you get habituated, you ignore like the loud sound and startle response, or we can say the corona and your like way of living, like now you have become less and less habituated. अब कहते हो अरे ठीक है ये तो होगा ही. So that is the habituation. So if we take the example, वो तो example जो कोरोना का है वो मैंने आपको just to make you understand the habituation वो बोला है. अब हम जैसे example लेते हैं कि you are wearing the cloth is continuously touching to your skin. Okay, the cloth is continuously touching to your skin. Initially जब आप पहना you become aware because of the touch sensation, but it continuously keep on touching or stimulating that touch receptor over here. So what happens, the amount of the neurotransmitter released in the successive response, it will decrease gradually. And why it will decrease gradually? Because of the decrease in intracellular calcium. Why decrease in the intracellular calcium? Because of the gradual inactivation of the presynaptic calcium channel by repeated action potential. So we can say because of this touch receptor sensation, it is touching, this repeated stimulus is happening, the presynaptic calcium channel, they will decrease in responding. And what was the response? To open up of the calcium channel. So less and less number of the calcium channel will open with the successive stimuli. Like first stimulus, say if you take the example of 100 calcium channel, they open up. Second stimulus, third stimulus, say if you take the example of the 40th stimulus, then instead of the 100 there will be 60 channel opening. So it means there will be less calcium entering into the presynaptic terminal. So intracellular calcium will get reduced. If there is reduction in the intracellular calcium, less available of the calcium to do the exocytosis of the neurotransmitter. So this neurotransmitter will get decrease in the release of the neurotransmitter. That is the short term mechanism. Now लॉन्ग टर्म मीन्स, ये तो हमने एग्जांपल लिया है, जैसे आपने फॉर जो क्लॉथ पहने हैं, कपड़े पहने हैं फॉर फ्यू आवर्स. लॉन्ग टर्म मीन्स फॉर वीक्स और डे, लाइक मंथ्स, ए पर्टिकुलर स्टिमुलस यू विल गेट हैबिचुएटेड. जैसे आज हुआ है और आपका 6 मंथ्स बाद होता है वही सेम स्टिमुलस, और ईयर बैक होता है आफ्टर फ्यू ईयर्स, इवन देन यू वॉन्ट रिस्पॉन्ड. तो उसमें तो आपका ये नहीं होगा ना फॉलो कि कंटिन्यूस स्टिमुलेशन है जिससे देयर इज रिडक्शन इन द कैल्शियम आयंस. इट हैपन्स ड्यू टू द नंबर ऑफ द साइनेप्टिक एंडिंग एंड एक्टिव जोन, they will get decreased. What does it mean? It means, say this is the neuron and it has got many synaptic terminals, and this is the second neuron where it has to respond. So either this number of the active zone, like initially if there are the 3 zones, now they will become either the 2 will stay active or only 1 will stay active. That is, number of the synaptic ending is reduced. Instead of the 3 there are 2, or out of these 3 there may be 3 or there may be 2, the active zone which are releasing the neurotransmitter, it is getting decreased. That is the long term mechanism of the long term habituation, and this is the mechanism of short term habituation. So don't get confused. If anybody asks you, like, write a short note on the habituation, write about what is habituation, what is the mechanism of action, write this thing, only this part, the calcium, forget about this long term one. Okay. Now second is opposite of the habituation is sensitization, exactly opposite of the habituation. Like initially there will be less response, and if you keep on increasing the successive stimulus, there will be increase in the response. So increased responsiveness to the innocuous stimuli that follow the presentation of a strong or noxious stimuli, that is called as sensitization. Now the noxious stimulus, it causes discharge of the serotonergic neuron. Now the example is, let me tell you, say if we draw, see the perfect example is, there is one neuron, okay, this is the sensory neuron, the presynaptic neuron we will talk about. Now if this is the postsynaptic neuron, okay, this is the postsynaptic neuron where it is happening. The third one, there is a noxious stimulus. If there is a association of the noxious stimulus with this one, okay, association of the noxious stimulus. Now initially, like say the stimulus is happening over here, and this stimulus will generate the action potential in this presynaptic neuron. It will release the neurotransmitter, and that released neurotransmitter will act over this postsynaptic neuron. Now if along with that stimulation there is one more neuron that get activated, and this neuron has got its ending on the presynaptic neuron. So this neuron is called as facilitator neuron. What does it do? It facilitates the response of the presynaptic neuron. And what is the response of the presynaptic neuron on generation of the action potential in it? It will release the neurotransmitter. It means this facilitator's neuron will increase in the release of the neurotransmitter. से आपने कुछ, जैसे क्या होता है कि जस्ट एक द, आई एम जस्ट ट्राइंग टू गिव यू देसी एग्जांपल कि जिससे आपको याद रहे कि आपके एक थप्पड़ मारा, जैसे बच्चे को थप्पड़ मारते हैं इनिशियली, तो बच्चा उससे कस्टम हो जाता है. नेक्स्ट टाइम जब आपका हाथ ही उधर जाएगा ना, तो वो पहले ही अवेयर हो जाएगा. इसका मतलब क्या है, स्टिमुलस तो सेम रहा, स्ट्रेंथ तो वही था, फर्स्ट टाइम स्लैप और द सेकेंड टाइम This is a very rude or very bad example, but to make you understand I am giving this example. Okay, so आपका second stimulus है, it is almost the same as the first one, but that noxious stimulus, that is the facilitator, जो आपको पता है कि इसको थप्पड़ पड़ेगा, दर्द होगा, that painful, it will make the person to release more and more neurotransmitter, और जिससे आपको जो रिस्पॉन्ड करना है, जैसे आप स्लैप करते हो किसी को, क्या रिस्पॉन्ड होता है, टेकन ए बैक, मतलब वो हटने की कोशिश करेगा. तो सेकंड टाइम क्या है, जैसे ही स्लैप के लिए हाथ उधर जाएगा वो पहले ही हट जाता है. तो पहले क्यों हटा, मीन्स दैट रिस्पॉन्स हैज स्ट्रेंथन्ड, एंड व्हाट इज रिस्पॉन्सिबल फॉर दैट रिस्पॉन्स टू बी मेक स्ट्रॉन्गर, more and more release of the neurotransmitter. So this noxious stimuli, this facilitator, it increases the release of the neurotransmitter. How does it increase? See, this, say this was the neuron, I will just try to draw a diagram of this neuron, and this second one was the noxious one. Now what does this noxious one do? It releases the neurotransmitter, that is serotonin. Okay, serotonin. Now this serotonin, it will get attached at the presynaptic neuron. There are the serotonergic receptors. Now what does this serotonin do? This serotonin, it will act over there, and one second, let me check. Yes, this one, this neurotransmitter is the serotonin. It attaches to the receptor at the presynaptic neuron. This is the presynaptic neuron. It will attach to this serotonergic receptor, and there will be the activation of adenylyl cyclase. This enzyme, what does adenylyl cyclase do? More and more synthesis of the cyclic AMP. Now increased cyclic AMP will activate certain protein kinases. More and more protein kinases, they will get activated. So because of the increase in the protein kinase activation, what does they do? They will phosphorylate of certain part of a potassium channel. Okay, like say at this neuron there are the potassium channels too, right? Like say the action potential is coming, this action potential, generation of the action potential, and then there will be this part, the second part, when it is repolarization. Repolarization happens because of the efflux of the potassium, right? Efflux of the potassium. So potassium channels are there. Now because of the phosphorylation of certain part of the potassium channel protein, they will get closed. So because of the closure of the potassium channel, potassium won't move out. So reduced potassium current in the action potential, what will it do? Because if there is no repolarization happening, that action potential will prolong. So prolongation of the action potential happens, and like say this action potential was supposed to die at this thing, but instead of this repolarization happening over there, it will go this way, like say this prolonged. So for this increased duration of the action potential, means for this increased duration the action potential stays, and if action potential stays, what does it do? It will, when the action potential reaches at the nerve terminal, it will open up the calcium channel. So because of the longer duration or the prolongation of the action potential, there will be more and more opening of the calcium channel, and more opening of the calcium channel, more entry of the calcium, and more neurotransmitter is released. That's how this sensitization happens. Like the first stimulus happened, it generated certain response, and if that stimulus is ending up is associated with a noxious stimuli, the second stimulus of the same strength, or the third or the repeated successive stimulus of the same strength, will generate more and more response because of the association of this noxious stimuli, or we can say this facilitator neuron. This facilitator neuron acts via release of the serotonin, and it increases the action potential duration. That is the short term effect for certain hours. For the long term, for certain days or the weeks, what happens? These protein kinases, see, these protein kinases of cyclic AMP, they are the second messenger system. आपने जो receptors में पढ़ा है ना कि first messenger, second messenger, how does certain hormones or certain neurotransmitter they work in the body. So these protein kinases, they either decrease or increase certain synthesis of the proteins, or they phosphorylate means activate or inactivate. For the short term, they will activate certain phosphorylation of the protein. For the long term, they will bring about the effects by changing the genetic information, means they will phosphorylate certain transcription regulator proteins. Like because of those transcriptional proteins, the synthesis of the synaptic connection will increase. If they bring about the change in the synthesis process or protein synthesis machinery, then that effect will stay for a longer duration. That is called as long term effect of the neurotransmitter. So, that is the mechanism of action of habituation and sensitization.